Hello, I am Yogesh, and in this video I will be discussing paper 4 AS level physics component 42 October November 23. So first question is define the radian. So suppose that there is a circle of radius r. Now if I consider an arc of length r that is equal to radius, then the angle subtended at the center of this circle by that arc is 1 radian. Means what is 1 radian? Angle subtended at center of circle when arc length is equal to the radius. Second question is the minute hands of a clock revolve at constant angular speed around the face of a clock, completing 1 revolution every hour. A small piece of modeling clay is attached to the hand with its center of gravity at a distance L. So this is clay piece and the center of gravity is at the distance L from this fixed end. Now we have to calculate the angular speed omega of the minute hand in this question. So in this question it is given ki it is completing 1 revolution every hour, and we know that time period is the time taken to complete 1 revolution. Time period is time taken to complete 1 revolution. So this means ki value of time period here in this question t is equal to 1 hour, or if we will convert it into second, it will be 60 into 60, that is t is equal to 3600 second, and we have to calculate the angular speed omega of the minute hand. So angular speed omega is given by the expression 2 pi by t. So if we will substitute this value, it will be 2 into 3.14 divided by 3600, and this value come out to be 1.7 into 10 raised to power minus 3 radian per second. C part, during the time interval of 1400 seconds, the center of gravity of the piece of modeling clay moves through a total distance of 0.44 meter. So we have to calculate the angle through which the minute hand moves in this time interval. Now here the time interval is given 1400 second, t is equal to 1400 second, and total distance moved is given 0.44 meter. Distance moved is given 0.44 meter, and we have to calculate angle. So for calculating angle we don't need this value here, because we have a relation theta is equal to omega t, and omega we have calculated in the above part. So it is 1.7 into 10 raised to power minus 3 multiplied by time 1400 second. So on solving we will be getting angle 2.4 radian. That's it. Now in the second part we have to determine distance L. So I am drawing a diagram. Here is the modeling clay, and this is fixed point, and this distance is L. We have to determine this distance, and so if you will see in the statement, the distance moved by the center of gravity is given 0.44 meter, and when the center of gravity moves this distance 0.44 meter, the angle is 2.4 radian. This means here if this angle is 2.4 radian, this arc length is 0.44 meter, and we have a relation theta is equal to arc by radius. And here you can see in this question, this length L will act as a radius. So substitute the values. Theta here is 2.4 is equal, arc is 0.44 divided by radius. Radius here is L. So L will come out to be 0.44 divided by 2.4. So L here is 0.18 meter. Now third question. Calculate the magnitude of centripetal acceleration of the piece of modeling clay. For centripetal acceleration, calculate the magnitude of the centripetal acceleration of the piece of modeling clay, and we know that centripetal acceleration is given by v square by r or omega square r. So here I will be using this relation omega square r. So omega I have calculated 1.7 into 10 raised to power minus 3 square multiplied by radius. So radius here is the length that we have determined into 0.18, and we will be getting 5.2 into 10 raised to power minus 7 meter per second square. So you can see that this centripetal acceleration here in this case is having a negligible value, or you can say very small value. Now D part is, use your answer in C3 to explain why the variation with time of the magnitude of the force exerted by the minute hand on the piece of modeling clay is negligible, as the minute hand undergoes one full revolution. Now, as I have told you in the above part of the question, third of C, that centripetal acceleration we have calculated 5.2 into 10 raised to power minus 7, and this value here is very small. If I compare this value with the value of g, that is g is equal 9.8 meter per second square, and centripetal acceleration here is 5.2 into 10 raised to power minus 7 meter per second square. So this value is very small, or you can say this is negligible if we compare it with acceleration of free fall. So if and force is given as mass into acceleration, and if acceleration is very small, then the resultant force will also be very small. Therefore, its effect will be negligible. So we will write here that centripetal acceleration acceleration is negligible compared with acceleration of free fall. So resultant force is negligible as compared with weight of clay. So question 1 done. Now let's move on second question. Second question is, define gravitational potential at a point. So gravitational potential we define, like gravitational potential phi is defined as gravitational potential energy per unit mass, that is U by m. So, and gravitational potential energy, we know it is the work done in bringing a mass from infinity to that point. So gravitational potential will become work done per unit mass. In bringing a mass from infinity to the point. Now, second question is, the moon may be considered to be an isolated uniform sphere of radius 7.3 into 10 raised to power 22 kg and radius. So, we are given mass and radius. Calculate gravitational potential at the surface of the moon. Give a unit with your answer. Now, gravitational potential is given, phi is equal to minus gm by r. So, it will be g, gravitational constant value, it will be given to you in the paper. So, it will be 6.67 into 10 raised to power minus 11 multiply mass is 7.3 into 10 raised to power 22 divided by 1.7 into 10 raised to power 6. So, in calculation we will get gravitational potential as minus 2.9 into 10 raised to power 6 and unit. Here I have told कि gravitational potential is potential energy per unit mass. Potential energy units are joule and for mass it will be kg. So, units for, here we can write joule per kg. Joule per kg will be the units for gravitational potential. Now, let's move on B part of this question. An isolated uniform spherical planet has gravitational potential phi on its surface and a particle of mass m is projected vertically upwards from the surface. The particle is given just enough kinetic energy to travel an infinite distance away from the planet, escaping from the gravitational pull without any additional work. So, determine an expression in terms of m and phi for the gravitational potential energy EP. So, EP, as I have explained, कि phi is equal to gravitational potential energy per unit mass. So, gravitational potential energy EP will be equal to phi times m. So, it will be like phi times m. So, this is expression. Now, in second part, show that the speed at which the particle is projected from the surface planet is given by v is equal to minus 2 phi square root. Now, in this question, like we have to use the statements from here. The particle is given just enough kinetic energy. Enough kinetic energy here it is given means कि as soon as it will reach the infinite distance, its kinetic energy will become 0. So, the point where the object is reaching or the particle is reaching, at that point its kinetic energy will become 0, and we know that कि at an infinite distance away from the planet potential energy is 0. So, we can write कि kinetic energy plus potential energy will be equal to 0, that is half mv square plus phi m is equal to 0 or half mv square is equal to minus of phi m. M and m will cancel out and v square here is minus 2 phi, or you can write v is equal to square root of minus of 2 phi. Now, next question C part is, a particle is moving upwards at the surface of the moon. Use your answer in A second and the expression B3 to determine the minimum speed. So, for minimum speed calculation we have already calculated an expression in the above part that v is equal to minus of 2 phi square root. So we have to substitute the values only. Minus 2 into value of phi, value of phi is minus 2.9 into 10 raised to power 6. So this value we will substitute here. Minus 2.9 into 10 raised to power 6 and square root. So this value will come out to be 2.4 into 10 raised to power 3 meter per second, or you can say this is 2400 meter per second. In but hydrogen may be assumed to be an ideal gas. The mass of hydrogen molecule is 3.34 in 10 raised to power minus 27 kg. Calculate RMS speed of hydrogen molecule in hydrogen gas, that is at temperature 400 Kelvin. So here we have to use the concepts of kinetic theory or thermal physics, where the kinetic energy is given as 3 by 2 kT and half mv square. Here v is the RMS speed. So on equating these two equations, we will get a equation like this: half mv square is equal to 3 by 2 kT. This 2 and 2 will cancel out, so we can write that v is equal square root of 3 kT divided by m, and on substituting, k here is Boltzmann constant. On substitutions, we will get 3 into 1.38 into 10 raised to power minus 23 into 400 divided by mass m, that is 3.34 into 10 raised to power minus 27. We will get RMS speed as 2200 meter per second. Now E part is the surface on the moon reaches a temperature of approximately 400 Kelvin when in direct sunlight. Use your answer in C and D part to suggest a reason why the moon doesn't have an atmosphere. So here escape velocity we have calculated 2400 meter per second, and the RMS speed of hydrogen molecule is 2200 meter per second. Now you might think that if RMS speed is less than the escape velocity, then the molecules should not escape from the surface and atmosphere should exist on moon. But RMS speed is the average speed only. This means there will be certain molecules which will be having speed greater than RMS speed, V greater than 2200, and if V will be much greater than 2200, then those molecules will exceed the value of escape velocity, that is 2400 meter per second. Therefore they will leave the surface. So the answer you will write here is ki as the RMS speed is average, but many molecules have speed greater than escape speed. Therefore, the moon doesn't have an atmosphere consisting of hydrogen. Question is, state what is meant by the internal energy of a system. Now, internal energy, to explain internal energy, let me give you an example. Suppose that there is a stone, and if you are heating this stone, if you provide heating, then what will happen to the stone? Whether there will be change in the kinetic energy of the stone or change in the potential energy of the stone, you will say no, it's fine. If there is no change in kinetic and potential energy, then where does this heat energy going? From here the concept of internal energy come कि when you heat this stone, the energy is used in increasing the, when you heat this stone, The energy is used in increasing the energy of the atoms that make this stone or the molecules that make this stone. So their energy is increasing. So that energy of kinetic energy or potential energy of the stone, of internal molecules of the stone, is known as internal energy of a system. So what is internal energy? So you will write sum of the, it is defined as sum of the random distribution of kinetic and potential energies of its atoms or molecules. Now B part is use the first law of thermodynamics to explain what happens to the internal energy of a spring when it is stretched at constant temperature within its elastic limit. We know that the internal energy is given as delta U is equal to Q plus W, where W is the work done and work done is given as P delta V. So when a spring is stretched, so this means ki work is done on this spring, and if work is done on this spring, therefore potential energy increase. But here it is stretched at constant temperature and there is no information of supplying heat, so no thermal energy is supplied. Therefore, as when you will supply thermal energy to the molecule, they starts moving with more velocity and kinetic energy increases. But in this case, no thermal energy is supplied, so kinetic energy do not change. Kinetic energy doesn't change. So as per thermodynamics first law, here Q is 0, but work is done on the gas, on the spring. Therefore, total energy or total internal energy will increase in this case. Second question, sample of water when it evaporates from a rain puddle on a hot day. So what will be the effect on its internal energy? Here it is mentioned ki hot day, this means thermal energy is supplied. Thermal energy is supplied, and evaporation is a case of expansion. This means work is done on the work is done by the water, but the expansion of water or change in volume here will be very small if you use this equation delta U is equal to Q plus W. Then the change in W value is much less as compared to the change in Q value. So Q value will dominate, that is Q value is thermal energy supplied. So therefore the internal energy will increase. Why? Because more thermal energy transferred than work done. So internal energy increases. Let's move on next question. Question number 4. An electron in a metal rod moves randomly about a mean position. When an alternating voltage is applied to the ends of the rod, the mean position can be considered to oscillate with simple harmonic motion about the axis of the rod. So this mean here, if this is mean position and this is axis of the rod, this mean position is undergoing simple harmonic motion, and the variation with time t of displacement x of mean position is given, graph is given, and we have to determine in first part the amplitude of the oscillation. We know amplitude is the maximum displacement on either side from mean position. So here you will see the mean position is this. This is mean position, and this is the maximum position, and if you read out these values, this value will come out to be, wait, so this value will come out to be, here the gap is 0.4, so this value will be this value will be 7.2. So this value is 7.2 and here this value is 3.6. So amplitude will be 7.2 into 10 raised to power minus 15 minus 3.6 into 10 raised to power minus 15. So it will come out to be 3.6. So it will come out to be 3.6 into 10 raised to power minus 15 meter. Let's move on second question. Determine the angular frequency of the oscillation. And for angular frequency, we know that omega is given as 2 pi by t. And if omega is given as 2 pi by t, we have to note down the value of time period from here. Time period here is given, so the cycle is starting from this position and again ending at this position. So this is 0.2. So it will be 2 into 3.14 divided by 0.2 into 10 raised to power minus 6. So on solving this, you will get 31.4 radian per second, or you can write, sorry, it will be 31.4 into 10 raised to power 6 also. Let me correct this, here it is minus 6. You can write 3.1 into 10 raised to power 7 radian per second. Third question is, use your answer to show the maximum drift speed V naught of the electron is this. Now maximum speed we have to calculate. Now drift speed here. So if you will see, the electron moves randomly about a mean position, and mean position is oscillating with simple harmonic motion. So for maximum drift speed you can write V maximum V naught is equal to omega x naught, where omega is angular speed and it is 3.1 into 10 raised to power 7, and x naught is the amplitude that we have calculated, 3.6 into 10 raised to power minus 15. So on solving this, you will get 1.1 into 10 raised to power minus 7 meter per second. So this is the drift velocity of the electron. Now B part. The road has a cross-sectional area of 4.3 centimeter square and contains a number density of conduction electrons 8.5. So we are given with values of area is given, that is 4.3 into 10 raised to power minus 4 meter. Number density n is given. All of the conduction electron may be assumed to be oscillating in phase with the same amplitude. Okay. We have to calculate I net naught of the maximum current. So drift velocity is given, and we know there is a relation between current and drift velocity, that is I is equal to NAE VD, where N is the number density of charge carriers, A is area, E is the fundamental charge of an electron, VD is the drift velocity. So on substitution we will get N is 8.5 into 10 raised to power 28 multiply 4.3 into 10 raised to power minus 4. Charge is 1.6 into 10 raised to power minus 19. And drift velocity we have calculated 1.1 into 10 raised to power minus 7. On solving this equation, you will get I naught is equal to 0.64 ampere. Second part, we have to sketch the variation of current in the rod with time t between 0 and t is equal to 0.40. We have this graph here, displacement versus time graph we are having. And displacement versus sine graph here is sine curve, sine wave it is. And current here is related to VD. Okay. And x for displacement, so it is a sine curve. And we can write that it will be x naught sine omega t. So V will be V naught cos omega t here. So current will also be I naught cos omega t. So cos curve for current we have to draw, cosine curve. And we know that if it is a cosine curve, then at time 0, if t is equal to 0, the current I will be maximum, because cos omega t is equal to cos 0 and cos 0 is 1. So I will come out to be I naught. So at time t is equal to 0, this value will be maximum I naught. Now we have to draw this graph. So it will be I naught and time period is 0.2. So it will complete the cycle here. So first let me mark these points, then I will draw the curve also. Yeah, so sorry, curve will be, yeah, this cos curve you have to draw. So this will be the curve. Now third is use your answer to determine an expression for I in terms of t. So equation for I have written here ki I is equal to I naught cos omega t, where I naught is maximum value and omega is the angular frequency. Maximum value is 0.64 and angular frequency is 3.1 into 10 raised to power 7. So equation will become I is equal 0.64 into cos 3.1 into 10 raised to power 70. Now fourth part is determine the RMS of current. So IRMS, we know that it is peak value or maximum value divided by root 2 times. So it will be 0.64 divided by root 2, and this value will come out to be 0.4 0.45 ampere. Now, fifth question, state Coulomb's law. For Coulomb's law, we know that if there is a charge Q1 and another charge Q2, let's these 2 point charges, and separation between them is R, then depending on the polarity of the charges may attract or repel each other with a force, and that force is electrostatic force. So Coulomb law gives a statement for calculating the magnitude of the force, and Coulomb's law states that electrostatic force or electric force between two charges is directly proportional to the product of charges and inversely proportional to the square of the separation between them. Now this definition might seem lengthy, but it is easy to learn this definition if you have learned this formula. F is equal to K Q1 Q2 by R square, where K is a constant, Q1 is first charge, Q2 is second charge, and R is another charge. And R is the distance between the two charges. Now B part is two identical oil droplets are in vacuum. The centers of the droplets are at distance 3.8 into 10 raised to the minus 6 meter apart, that is R is given. The droplets have equal charge and exert an electric force on each other of magnitude. This force is given. We have to determine the magnitude. So F is given as 1 by 4 pi epsilon naught. That K value is 1 by 4 pi epsilon naught here, into Q1 Q2 by R square, that is F is equal to 1 by 4 pi epsilon naught. Now two charges are identical, so let's say Q1 is equal, Q2 is equal Q. So it will be Q1 Q2 will become Q square divided by R square. So Q will be equal to F into 4 pi epsilon naught into R square under root. So Q will be equal to 6.3 into 10 raised to power minus 17 multiply by 4 into pi into absolute naught here is the absolute permittivity, and its value is 8.85 into 10 raised to power minus 12 multiply R square, that is 3.8 into 10 raised to power minus 6, and we have to take the under root of this. So charge will come out to be 3.2 into 10 raised to power minus 19 coulomb. Now C part. One of the oil droplets is now placed between two horizontal metal plates as shown. A potential difference of 1200 volt is applied and the oil droplet is stationary and in equilibrium. State the sign of charge on the oil droplet. Now if oil droplet is here, then its weight should act downward. So to make it stationary here, this means another force should act in upward direction. Here you can see the positive plate is here. This means it can only attract this ball if this ball is negatively charged. So sign of the charge on oil droplet will be negative. Now second question, draw 4 lines to represent electric field. So this question is very simple. You will draw field lines, 4 field lines, 1, 2, 3, 4. From positive to negative you will draw, and this is very important to draw the arrow to show the direction of electric field. Now distance between the plates is 5.2. Determine the mass of the oil droplet. Here it is given that the oil droplet is stationary and in equilibrium. This means net force is 0. So weight mg is balanced by electric field here. So mass we have to calculate. So mass is equal to QE by G. But Q we know, we have calculated, G value we know, E is not given, we are provided with value of V, and we know that E can be written as V by D, and D here is given, so M will become Q V by GD. So it will be 3.2 into 10 raised to power minus 19 multiplied by 1200 divided by 9.8 into 5.2 into 10 raised to power minus 2. So this mass will come out to be 7.5 into 10 raised to power minus 60. D part is